Morning everybody, welcome to another edition of the Lab 207 webcast. My name is Mr. Kite and I'll be hanging out with you today as we continue on in our series about the living world. Topic for the day is going to be feedback control. After I get you your objectives, I promise you this one is going to be short. So by the end of this video, be able to do the following. Define the terms regulator, conformer, homeostasis, and acclimatization, and describe ways in which homeostasis is maintained through feedback control. So a little vocabulary first, and then a couple concepts. So words that you need to know as we discuss this topic. The first one is a regulator. This is an organism that is able to regulate its own internal environment. So things can go on in the outside world, it can get warmer, it can get colder, but control of body temperature and I guess homeostatic maintaining mechanisms, that is all internal to the body of a regulator. An example would be us. We regulate our own body temperature, metabolic function, etc. Then you've got a conformer where internal changes are regulated by external stimuli. So this would be something like a cold-blooded organism, an ectotherm. Temperature goes up and down outside. Their body temperature goes up and down along with it. They conform to the external environment. Homeostasis is just balance, and this is the, I guess, healthy working state of any organism's body. If you are sick or injured or something, you are not in homeostasis. And finally, acclimatization. This is a gradual process by which an animal adjusts to changes in the environment. So an example of this would be when I go back home to Colorado, I go from sea level to roughly 5,000 feet elevation. The air is thinner, the air is drier, so over the process of a week or so, my body will start to produce more red blood cells to carry more oxygen to meet the demands of that area. Know that this is not adaptation in the terms of evolution. This is just a short-term I guess change in the internal environment to match what's going on with the external environment. So now let's talk about a couple of concepts. Feedback is a system of controls that either start or stop a process. The classic example of a feedback control, a negative feedback control, is a thermostat. Most of the homeostasis in our body is regulated through a negative feedback. So let's talk real quick about how a negative feedback control works. So let's say that your home has got a set point of 70 degrees. Know that if there is like a set point, this is the point things have to say, it's called a set point. If let's say you maintained your house at a temperature between 68 and 72, that is known as a normal range. But either way, here's how this works. If the temperature of your house drops below 70 degrees, that is going to trigger heat. Okay, your furnace will probably kick on, something like that. This heat is obviously going to warm up the house until it gets to 70 degrees, at which point the heat will shut off until we drop down below that 70-degree range again, and then heat kicks back on until it warms up, and then it shuts off again. So there's a lot of mechanisms. Most mechanisms in the body that are regulating some sort of internal process work on this idea of a negative feedback, where the absence of something will trigger some sort of response, or the presence of something will trigger some sort of response. The body will kick in, its process will go until things have been balanced, and then it'll shut off. Example of this would be body temperature. Your body gets too warm and the process of sweating is triggered. Through evaporative cooling, the body will cool down, and once your body hits a normal temperature again, the process of sweating will shut off until you get too hot again. So we are trying to respect the set point, and we are going to work until we hit that set point and then shut off the process. Now, the opposite of negative feedback is a positive feedback, and this is like where negative feedback shuts off a process, positive feedback pushes a process through to completion, or kind of like full steam ahead. Best example of this that I can give you is childbirth. As the baby grows, it presses up against the uterus and the cervix of the mother. That pressure against the cervix causes the uterus to contract, which pushes the baby even harder against the cervix, which causes the uterus to contract more. So this is trying to drive the process of childbirth through to completion, which is obviously birthing the baby. So just know that a positive feedback control is like rolling down a mountain, where the further down the mountain you go, the faster the process runs. Final thing for the day is alteration in homeostasis. So homeostasis, like I said, is the balance of the body. But where that balance is met might change day to day, season to season, or period in life to period in life. A couple examples of alterations in homeostasis. So obviously, puberty. Child hits somewhere between 10 and 13 years of age, and their hormonal levels in the body change very dramatically. So pre-puberty, when they're prepubescent, they had one homeostatic set point. Post-puberty or in the middle of puberty, they have a different set point. Another example would be menstruation in women. That 28-day monthly cycle includes hormones rising, hormones falling, and a bunch of things going on that is normal for the female body, but homeostasis from one day to the next might be different based on where in the cycle she is. And then a last example would be a circadian rhythm. We talked about those. They are regular rhythms that happen over a 24-hour period, usually have to do with us being awake or being asleep, and body temperature rises and falls along with our circadian rhythm. So usually in the evening when you're sleeping, your body temperature might drop down as much as a full degree, and when you're awake, it might go up as much as a full degree. So throughout that 24-hour period, our homeostatic set point is changing quite a lot. So I know that was really quick. I hope that that gave you at least a decent idea of the mechanisms that regulate our internal environment, our homeostasis, if you will. A couple of recaps. Remember that negative feedback is where a stimulus shuts down a process and you're trying to maintain a balance. Positive feedback is where you're trying to push a process through to completion. So that being said, thank you for joining us on the Lab 207 webcast. My name is Mr. Kite, and hopefully we'll see you again.